Hello, so in today's video, we're going to look at solving simultaneous equations with quadratic terms. So for example, this example here, so that's the example we're going to look at today. So we want to solve these equations simultaneously. So the first one here, 2x minus 3y equals 6. So I guess the thing to notice here is that this is a linear equation. We can tell that that's a linear equation because we have two variables, y and x, and they're both linear in x and y, or y and x respectively. So that's a linear equation. This second one here, I mean, it looks like a quadratic just because we got those quadratic terms here and there. But because of the y squared, this is actually not a quadratic in x. This is actually a hyperbola. So this graph is the shape of a hyperbola. So hyperbole, they either look like this, or they look something like that. In this case here, this graph would actually look like something roughly like that. I mean, not exactly like that. There'd be a kind of, I mean, this center would be shifted across, but something roughly with this kind of curved shape here, these two curved shapes, is what this graph here would look like. But we don't really need to worry about that in A-level maths. We don't need to worry about sketching these hyperbole, but we will be sketching in future videos equations which perhaps look something similar to this, but maybe a plus sign there instead. But we'll worry about that when we get there. So yeah, we want to solve these equations. I'll just copy them out again on the next slide. 2x minus 3y equals 6, and also x squared minus y squared, and then plus 3x equals 30. So there's a few ways we could do this. Well, actually, but there's two main ways we could do this one. So we could substitute it, so rearrange the first one for y and substitute that into the second equation, or rearrange the first equation for x and substitute that into the second equation. So either one of those would be fine. I'm just gonna, I'll call this number 1 and I'll call this number 2. So let's take number 1 and let's make y the subject of the formula. So we've got 2x. So if we just add 3y to both sides, subtract the 6, we get 2x minus 6 equals 3y. Divide both sides by 3, we get y equals 2 over 3x, subtract the number 2. 2 divided by 3 is 2 over 3, and 6 divided by 3 is 2. Negative 2 in this case, because that negative sign there. Yeah, so we get that. If we just plug this into, so plug this equation, plug into equation 2, so we get x squared minus, so y squared, so the square of this this expression here, 2 over 3x minus 2 all squared, and then this is equal to 3 times by sorry, not 3, 3x, sorry, plus 3x there. So plus 3x, sorry, I was looking at this bit here. So plus 3x equals 50. So we get that. And then it's just a case of simplifying the algebra. So we get x squared, and then subtract. So 2 over 3x squared, that's going to be 4 over 9x squared. And then again, just expanding the bracket. So 2 times 2 over 3x, subtract another 2 over 3x times by 2. So that should give us negative 8 over 3x. And then minus 2 times minus 2 is plus 4. So that should be what we get when we expand the brackets there, the square of this linear expression. So we get that. And then this plus 3x at the end there. And this is all equal to 50. I'm just going to make the writing smaller. Okay, yeah, so we get that so far. So now then, so now it's just a case of simplifying this. So x squared minus 4 over 9x squared, that's just 5 over 9x squared. Subtract negative 8 over 3x, that's just positive 8 over 3x. Subtract 4, negative 4. Plus 3x there. 3x is just actually the same as 9 over 3x. I'm just going to write 9 over 3x there, and that equals 50. Just to help me out adding these two terms together there, because they're common, they're like terms essentially. So we get 5 over 9x squared, and then plus 17. So 17 over 3x. And then what I'm going to do now actually is bring this 50 to the other side, to subtract 50 from both sides. And when I do that, I get negative 54 equals 0. We can now multiply everything by 9 to get rid of the 9 on the bottom there. And if we do that, we get 5x squared plus So 9 times 17 over 3. So that's just going to be the same as 17 times 3. And that's going to be 51x. And then 9 times 51, I can't do that in my head. So I'll do that on my calculator. 54 times 9 is negative 486. So we get that there. And this equals 0. So now at this point, we could, we could attempt to factorize it. But because A-level maths exams have calculators and we're allowed a graphical calculator which can solve these equations, it's probably easier just to use the graphical calculator. I'm not going to be, I can't really be bothered to factorize this quadratic here, to be honest. We could complete the square. Again, it's probably just going to be a little bit tricky just because we've got to factor out this 5 from the first two terms here. I'm probably just going to use the quadratic formula. But of course, you can use the calculator, the graphical calculator, if you have one, to solve this equation here. And if we use the quadratic formula, we get negative 51 plus or minus the square root of b squared. So 51 squared minus 4 times 5 times negative 486 under the square root sign like that. And this is all divided by 2 times a. The a is 5. So 2 times 5, which is 10. So we get that. So now calculating this, I'm just going to put the surd all into my calculator. So 51 squared, and then subtract 4 times 5 times negative 486. So under this square root, I get minus 51 over 10 plus or minus, sorry, write that again. So plus or minus the square root of 12321. All divided by 10 there. If I square root 12321, I get 111. Okay, so I get minus 51 over 10 plus or minus 111 over 10. Okay, so now we're getting closer. So we just got to simplify the final result we get here. I'm just going to again move this, try to move this up there. So now we're going to get two answers. So therefore, x equals minus 51 plus 111 over 10, or x equals minus 51 minus 111 over 10. And if we just work those two values out, so 111 take away 51 gives us 60. 60 divided by 10 is just 6, so x equals 6 is one of them. And then this second solution, negative 51 take away negative 111 divided by 10, we get negative 16.2. And then you can always check your answer in the calculator just to make sure you've got exactly what you want. So your A value is 5, your B value is 51, your C value is negative 486. And so when we solve that, yeah, we get those two solutions. X is 6, and X is negative 16 over 2. Okay, perfect. So now we've got the X values. We've just got to find the Y values, because obviously we want to solve the equations for Y2, because that's the whole point of the question. So now we just substitute in these values into the equation. So let's just pick this this linear equation up here, just because that's easier to deal with. So this up there. So if we just substitute the values into that, we're going to get y equals 2 over 3 times 6 take away 2, which gives us, so 2/3 of 6 is 4, 4 take away 2 is 2, so we get 2 with that there. And then this one, again, we're just going to plug our x value into this here. So we get y equals 2 over 3 times negative 16.2 minus 2. And then if we just, I'll just put this into my calculator. So 2/3 of negative 16.2, take away 2. So I get minus 12.8 with that. So it looks like the solutions, I'll do this in blue over here. So solutions is going to be, so x is 2 and x is 6. So when x is 6, y is 2. And when x is negative 16.2, we get y is negative 12.8. So you get that solution there, that pair of solutions, and this pair of solutions there. And this solves the simultaneous equations. So that's one way in which we could solve these simultaneous equations. So when you get a question like this, you can just follow this procedure where you rearrange one of the equations, plug it into the second one, do some algebra, solve the quadratic, and then plug the results back into your linear equation to get the y values. So that's how you would solve these equations.